students, guests, and most importantly, the graduating students. Thank you all for giving me this opportunity to be part of this joyous day. My congratulations to the graduating students, the pioneering students. This day is also called the commencement day, since you are indeed commencing your life today as a professional. You are very lucky to have had two of the finest professionals of this country as your chairman and your director. I have known Kiran for over 40 years. As he was leaving the Indian Institute of Management, Ahmedabad, I went there to work in the computer center there. I have known Pankaj very well, I must say, for the last 15 years. I worked very closely with him when he came to Infosys on sabbatical for 2 years from the Indian Institute of Technology, Kanpur. He headed our quality and productivity group and demonstrated that he is not just a very good academic in computer science, but also a very good software professional by leading the company to become the first Indian software company to be certified as level 5 compliant of the capability maturity model of the Software Engineering Institute at Carnegie Mellon University. Based on that experience, he has written 2 highly regarded textbooks. Of course, he has written 5 textbooks in all. I have learned a lot from my interactions with him, both in software engineering as well as in leadership. In my opinion, he is clearly today one of the finest leaders of an educational institution on a global scale. As the chairman said, a few of you will go on to do your graduate studies, and most of you will start your career as software professionals. Unfortunately, almost all of the advances in the Indian software industry, other than the global delivery model and the 24-hour productive day, advances in software engineering, quality, productivity, security, and user interface design, just to name a few, have come from Western nations. Except for books written on operating systems by my friends Professor Damdare and my successor at PCS, Sri Gudbole, and a couple of books on software engineering and quality by Pankaj Jalote. Every book we use has been written by people who worked abroad. Every gadget we use and every invention that we see around us have been invented abroad. Why is it so? It's a very important question that we should all think about. I believe it is because we in India do not use much of what is taught in the colleges and what we do as professionals. For us, education ends with passing the last examination in the college. Our students put enormous focus on rote learning and passing the examination. They hardly remember even fundamentals learned from their college education. They do not see college education as the instruments to solve problems around them, which is the fundamental aspect of the outcome of education in Western nations. Making education purposeful is a key aspect of gaining recognition for our education system. No wonder then, my young friends, that there is no Indian institute of higher education in the top 200 in Shanghai rankings. I hope IIIT-Delhi will be the first one to be there, and knowing Pankaj, I have no doubt at all that under his leadership, every one of you associated with this wonderful institution will do everything necessary to make sure that IIIT-D becomes the first institute of higher education in the top 200 in Shanghai Index. In addition, the class of 2012 from IIIT-D has to take the first steps to set this right. As Pankaj pointed out, what you people achieve when you go out of the four walls of this institution will contribute significantly to enhancing the reputation of this institution. Therefore, there is a very heavy responsibility on your able shoulders to make sure that IIIT-D indeed becomes the institution of choice for the forthcoming generations interested in the area of computer science. Having thought about these issues, I said I would speak on an unusual topic today. I give lots of convocation addresses in India and abroad. And most often I speak about the importance of being a good citizen of whatever society these students are passing out. Today, I thought I would speak on a different issue because having known Pankaj, I was pretty sure that he would have exhorted you people, first through leadership by example, the importance of being good citizens. I was quite moved when he said that even before he exhorted you people to contribute 1% of what you earn towards the corpus fund, he instructed his office to deduct 1 month's salary every year towards the institute. I think that is the finest example of leadership example. Therefore, I said, I'm not going to speak on being a good citizen, and I am going to speak on being a good professional. Therefore, today, I'd like to speak to you on how you should use the outcome of these 4 years of your undergraduate study and 2 years of graduate study, which form the foundation of your future accomplishments, whether in pursuit of a higher degree or as a software professional. How do we use our education to make the society around us a better place? We do it by learning fundamentals taught in the college, ensuring that these fundamentals become part of our DNA in our work, constantly upgrading our understanding of these fundamentals by being connected with advances in academia and industry, and by applying these fundamentals to the transactions in the real world around us day after day. We do it by seeking opportunities to use these fundamentals to produce better products for our customers and to make our work more productive and comfortable, and in the process by inventing new ideas. My young friends, the easiest way to do this is to use your college education as a stepping stone for enhancing your ability to constantly learn new things and apply them to make life around you better. Every day, just ask how you can use your professional knowledge to make whatever you do faster, cheaper, and better. College education, as you all know better than I do, is all about learnability. Learnability is the ease with which you learn new things. It is also the ability to extract generic inferences from specific instances and using them in new, unstructured situations to solve problems. Such a learning paradigm requires that you have a clear grasp of a posse of fundamentals. For example, I learned the concept and mathematics of negative feedback and the power of modeling and simulation using negative feedback from my control theory class in my undergraduate years 47 or 48 years ago. I make it a point to use these ideas in my work even today. You will be surprised to know that I have used these ideas very successfully even as a CEO. If you studied operations research, then you should internalize at least the power of simplex algorithm, integer programming, and dynamic programming. Not being able to use the ideas of probabilities, Bayes' theorem, or those of uniform, normal, binomial, and Poisson distributions, having done a course in statistics, means you have wasted your time. If you studied a course on algorithms, which I am sure all of you have, you should at least know basic attributes and applications of a few important sequential, parallel, distributed, concurrent, event-driven, randomized, approximate, and genetic algorithms. I hope you know. You should understand the concept of P and NP hard problems. If you have taken a course on operating systems, you should be able to write the pseudocode for P and V semaphores. I hope none of you has forgotten that. You should be able to explain the concept of a critical region, LAN and WAN communications, memory allocation, file management, device drivers and interrupt handling, re-entry encoding, graphical user interface, scheduling, inter-process and inter-task communications, and virtual memory. I'm just naming a few ideas. If you took a course on databases, you should be able to explain at least the concept of B-star trees, transaction processing, normal forms, logging and recovery, distributed databases, and multi-phase commits. I can go on and on and on, but let me just say that you should focus on some fundamental ideas in each of these areas and internalize these ideas so well that they become part of the DNA of your existence. Why am I saying these things? It is because an important attribute of you as a successful software professional and a successful graduate student is to have these basic concepts on your fingertips and to constantly seek opportunities to make your work more productive and to produce the best quality of outcomes from your work. It is about keeping up to date on advancements in these ideas. It is about thinking how you and your team, these days most of graduate work is in teams, as you people know. Most PhD students work in teams and then they get their PhDs. Therefore, it is very important about thinking how you and your team can bring in transformational progress by leveraging the power of these ideas. How does one keep these ideas on fingertips? I will repeat some of the ideas I spoke earlier just to emphasize how important they are. First of all, internalize every one of the fundamental ideas that you learned in the college. That is, make sure you visit these ideas as often as you can by reading them often and seeking opportunities to use them as often as you can. One way of being in touch with them is to read and reread fundamental ideas from classical textbooks as often as you can during your spare time. Thanks to advice from some smart young people, I have created a library of some of the classics in computer science. I try to read them as often as I can. These days, I have become very, very, very slow in understanding technical stuff, but I still try. Reading them puts me in an uncomfortable zone, which makes me think. But when I start reading these textbooks, I get inspired by the smartness of ideas, by the smartness of those authors, and I realize how small I am. That motivates me to work harder and hopefully smarter in whatever else I do. That motivates me to think more carefully and relate my thinking to the real world around me. Let me name just 5 of the 70 and odd classical computer science books in my library. The Art of Computer Programming, 4 volumes by Donald Knuth. Modern Operating Systems by Andrew Tannenbaum. Computer Networks, a Systems Approach by Peterson and Davy. Mathematical Theory of Computation by Zohar Mana. Introduction to Algorithms by Corman, Leserson and Rivest. And Transaction Processing Techniques and Concepts by Jim Gray and Andreas Reuter. My suggestion is that you choose your own set of classical textbooks for your library and read them as often as you can. Some of you will perhaps not appreciate why you should read these books if your job is to be just a programmer. I'm glad to say that I was the first person in India to introduce the job title of software engineer in the private sector way back in 1976, when none of you was born. designs an efficient algorithm for the program based on what he or she has read from the manuals. On the other hand, an engineer like you performs the same task even better by leveraging the power of advances in the field. An engineer understands the theory behind every one of his or her design decisions in constructing an efficient algorithm for the program. For example, when I taught software engineers in the early days of Infosys, I first taught them fundamentals of algorithms, computer architecture, operating systems, and databases. The result was that these engineers understood how a simple read or write statement in a high-level language actually translated to machine-level commands to disk controllers. They also appreciated, for example, how one logical record access in their high-level programs might result in many physical accesses of the disk system. They learned how inefficient design of overlays in the program in those days of 16-bit computers. Fortunately, those are not the issues today because you have got 64-bit systems. But in our days, we operated with just 16-bit computers, and therefore the addressable space was only 64 kilobytes, and therefore we had to use overlays when we wrote long programs, which meant we had to reserve a certain part of the addressable space for overlays and bring in those overlays whenever they were needed to be executed. And what our youngsters learned was how the inefficient design of overlays in the program led to thrashing and therefore consequent slowing down of their programs. Performance, my young friends, is an extremely important aspect of quality. Generally, engineers appreciate performance engineering of systems better than just programmers. For example, the engineers I taught at Infosys understood the impact of key size, the size of the keys, and the logical block size on the number of levels in the B-star tree design of an index file. I'm sure all of you have read it, all of you know it, I don't need to explain it. They understood the power of normalization of databases to eliminate duplication of fields and thus avoid incorrect update of databases. In other words, every design decision they made was based on their understanding of theoretical concepts. Let me give you two examples of engineering skills bringing tremendous value to our customers at Infosys. An important customer of Infosys in Japan wanted us to review an existing system design for performance improvement. The end of the day batch programs were taking huge amounts of time and running into the online day. Our engineers reviewed the design of the programs and the database, made improvements based on their knowledge of theory, and reduced the end-of-day procedure from 12 hours to 1.45 hours. In 1981, when we were designing a large online application package, we found that the programmer productivity was hindered by the lack of a screen management software on the machine that we were using. Mr. Shibulal, the current CEO of Infosys, and I designed our own screen management package and improved the productivity of about 80 programmers in the team by as much as 25%. The engineers of Infosys have designed a modern real-time shopping experience software package by leveraging the advances in retail technology. This knowledge They gain not from textbooks, because these are really mostly on papers, in journals, etc. They gain this through their education, of course, but more importantly through internet, through attending conferences, and through colloquia that we have at Infosys. Therefore, my request to every one of you is to please join the weekly colloquia in your company or the university right from day one. If such a facility does not exist in the company that you're joining, please start one. Invite well-known experts from academia and the industry to give lectures on advances in areas of your work. Access internet to get the latest ideas in your area of work. Become a member of ACM and IIIE with subscription to at least an important special interest group. These professional bodies bring immense value to your work. They are the source of unlimited knowledge to improve your productivity and innovative capabilities. They open doors to interaction with global experts. Take examinations conducted by professional societies like IIIE. Such examinations help you to be up to date in the knowledge you require to succeed as a professional. These examinations help you to benchmark yourself with professionals on a global scale. They raise your confidence to tackle advanced problems in your workspace. They help you to innovate at the leading edge. Take part in programming and design contests held by professional bodies, by the industry, and perhaps by your own company. Such contests will help you retain your analytical and skills capabilities. They help you learn what your colleagues in the industry are doing to improve their innovation and their productivity. Please remember that the most important requirement to be a successful professional is to constantly update technical ideas you learned in your college. Ask how these ideas can be used to deliver better value to your customer, and how you can make your life and your team's life easier, better, and more productive. Any success as a professional requires that you develop a mindset of curiosity and respect for intelligence and knowledge. That means you should hold your teachers with the highest esteem, meet them as often as you can, and learn from them. Please listen carefully to people smarter than you at workplace and elsewhere. Develop the habit of spending at least an hour a day in enhancing your professional knowledge. Attend refresher courses conducted by your company, by your alma mater, or elsewhere. Of course, none of these will help if you do not practice pride in your nation and your profession, teamwork, discipline, good work ethics, honesty, courtesy, commitment, and hard work. Knowing Pankaj, I am sure he would have prepared every one of you to be worthy members of a high-quality professional team. My congratulations again and best wishes for a great future. Thank you.
Mr. Chancellor, sir, I request you to kindly present a memento to the Chief Guest on behalf of IIIT-Delhi.